This is Miss Scott coming to you with a video on how to balance simple chemical reactions with just a few easy steps and some diagrams. So let's go ahead and get started with the problem we have here. We have mercury oxide plus diatomic chlorine yields mercury chloride plus diatomic oxygen. So this would be an example of a single replacement reaction. One partner in a compound is switched out with one element, leaving somebody by himself, so single. So the first thing we have to do when we're talking about balancing reactions is to see, does the reaction as it's written follow the law of conservation of mass? And how I like to do that is just with some really easy diagrams. So the first thing I do is separate my before side, my reactants, from my after side or my products. Basically what the law of conservation says is that every atom that goes into a reaction has to come out of it. Alright, so I will start by drawing some diagrams of what I actually have. So our first one, HGO, so that's mercury oxide. I have one atom of Hg, mercury, and one atom of oxygen. I'm going to draw them so that they are touching one another. That shows me that they're one molecule. All right, it's one compound. It's one thing made of two atoms. The other reactant I have, Cl2. So this is going to be one picture with two chlorine atoms. So Cl, Cl. So that's my before side. My after side, I have HgCl. So again, that will be one picture. It's one compound with one mercury atom and one chlorine. And my other product, O2, so one picture with two oxygens. So is it balanced? It's really easy to see that this is not balanced. On this side, my reactants, I have two chlorines. Now my products, I only have one. Likewise, on my products, I have two oxygen atoms to only one over here. So I have to add more pictures in order to balance them. The trick to doing this is simply adding more of the pictures that you've already drawn. So I'm going to balance my chlorine first. I can balance that really easily. I need one more chlorine over here. I can't leave this Cl by itself because that would be like adding another product to the reaction. It has to be the same as the picture I already have. So for every chlorine atom, it's got to have the mercury attached to it. It's got to look like this picture up here. So now the chlorines are balanced. But alas, I've unbalanced the mercuries. Now I have two mercury atoms and only one over here. So I just go back to the other side and add more pictures until everyone's happy. So I'll add another mercury atom, and every mercury atom on this side, on the reactant side, had an oxygen attached to it. Now is everything balanced? I have two oxygens, two chlorines to two chlorines, and two mercury atoms to two mercury atoms. Everything is balanced here. So how do you show that in a written statement? What you do is you count how many times did I draw the picture. That will be this number here, the coefficient. So how many pictures of mercury oxide do we have? We have two. Each one has one mercury and one oxygen. How many pictures of Cl2 do we have? We have only one. Each one picture has two chlorine atoms. On my reactant side, I have two pictures of mercury chloride and only one picture. I only had to draw one set of diatomic oxygen. So that is your balanced equation.